Let's start with this quote from Leonard Euler: "Nothing takes place in the world whose meaning is not that of some maximum or minimum." We want to solve British Mathematical Olympiad BMO round 2 1996. The first problem, it says determine all sets of non-negative integers x, y, and z which satisfy the equation 2 to the x plus 3 to the y equal z squared. Before solving the problem, thanks for subscribing and like the video. So let's start. When you see this problem, you do what? Look, I want to solve this with simple methods. And before that, let me tell you all the things we need. If you know modula, or congruencies, or also divisibility, we can solve it easier. But because I want that the solution be useful for basic level students up to professional level, I will use basic methods that if you don't know modula, you understand. So suppose that we consider, at first I want to tell you something that are useful in the problem. GCD of a and a plus 2, I want to prove it is 1 or 2. How I can prove this? Let me tell you these things. You consider GCD of a and a plus 2. Let's call this one lemma 1. Okay? Consider it is D. We say, okay, D is GCD. GCD is what creates common divisors. So A is multiple of D. Like, for example, let me tell you, GCD of two numbers, for example, 6 and 8 is what? Is 2. 6 is multiple, because 2 is common divisor. 2 is divisor of 6, means 6 multiple of 2. So A is DQ1 and A plus 2 is DQ2. So if you subtract A plus 2 minus A2, it will be DQ2 minus Q1. So D times something, for example, suppose it is DQ3. So DQ3 is 2. By the definition of GCD, D always should be positive. So DQ3 is 2 and D is positive, so D can only be 1 or 2. If A is odd, for example, like 1 and 3, it will be 1. If A is even, like 2, 4, 4, 6, GCD will be 2. So the first thing I wanted to prove was this. Now let me tell you another thing, lemma 2. If, for example, a number is odd, if B is odd, then B squared is 8Q plus 1. It means that we should prove this. It means that when you divide B squared by 8, the remainder is 2. So let's prove it by lag the lemma 2. You say what? B is odd, so B is 2K plus 1. So B squared is what? Is 2K plus 1 squared. Or you can say 2K plus 1 times 2K plus 2K times 2K, 4K squared. 2K times 1 plus 2K. 1 times 2K plus 2K. 1 times 1 plus 1. So let me tell you something. If you know these basic things, you can use the timestamps in my description, go straight forward to the problem. It will be 4K squared plus 4K plus 1. So it will be what? You factor from 4K here in this part, it will be K plus 1, and that plus 1 is left. K times K plus 1 is product of two consecutive numbers, so it will be what? 2, for example, Z, or because we have Z, let's write W. So, or we can say Q here, because we need to use that 2Q, because product of two consecutive number is even, because if K is even, it is even. If K is odd, K plus 1 is even. So 4 times is 8Q plus 1. So we proved lemma 2. Now let's consider the main problem. It says non-negative integers x, y, z, 2x plus 3 to the y equals z squared. So let's solve this. Okay, so because I want to consider, for example, the remainder of these numbers when divided by what is useful? When divided by 4, remainder, or the students know mod is what they say mod 4. Remainder when divided by 4, when divided by 8, when divided by 3. All these things I want to consider. So Look, for example, if I want to see this remainder when divided by 8, it depends that x is 3 or more or less than that. Because look, if x is greater than equal 3, then 2x is, for example, 8t. It is multiple of 8. But for 0, 1, 2, we can't say that. So at first, I try to consider special cases. So let's consider at first y is 0. So the small cases I want to check x0, 1, 2, and y0. I want to check these small cases. And then after that, I say, okay, otherwise, x is at least 3 and y is at least 1. So I check 1, 2, 3, 4 different cases. I find the answers for these 4 cases. And after that, I consider x is at least 3, y is at least 1, and then try to prove the problem. So let's continue. If y is 0, you say what? 2 to the x plus 3 to the, replace y with 0 equal to z squared. So we can say what? 2x plus 1 equal to z squared. Take 1 to right hand side, it will be negative 1, z squared minus 1, or we can say subtract 1 from both sides. And then we subtract, we factorize z minus 1, z plus 1. Yes. So here, I said GCD of that their difference is what? 2. Look, it is, for example, something z plus 1 is z minus 1 plus 2. From lemma 1, I told you what? I told you when I have two numbers and a plus 2, their GCD is 1 or 2. So let's consider the first one, because their product is power of 2. So it will be 2a1, 2a2. Okay? And I know their GCD is what? Their GCD from lemma 1. From lemma 1, I said the GCD of two numbers that their difference are 2. A plus 2 here are z minus 1, z plus 1. Their GCD is 1 or 2. So do you agree? I know what? I know 2a1 is less than 2a2. Because it is z minus 1, it is 2 more than this. So if a1 is, for example, at least 2, for example, if it is 4, then, for example, it is 8 or 16, then their GCD will be what? For example, 8 and 4, 4. But we know their GCD can only be 1 and 2. So this number cannot be 4, because then their GCD will be multiple of 4. For example, it is 4, it is 8 or 16. Their GCD will be what? 4. But we know GCD of z minus 1 and z plus 1 by lemma 1 is only 1 or 2. So we can say 2 to the a1 can only be what numbers? Can you say? 1, yes, or 2, because we said if it is 4 or 8 or something else, then the GCD will be 4, 8, the other numbers, not 1 and 2. So we conclude. So the first case, if 2a1 is 1, this 2a1 is what? 2 to the a1 is z minus 1. Z minus 1 is 1, so z is 2. So let's replace, if z is 2, it will be what? 2 minus 1, 1, but 2 plus 1, 3. So then 2 to the x will be 1 times 3 equals 3. And we know it is impossible, contradiction. And 2 to the a1. The contradiction sign in some countries, they write contradiction. In some countries, like Hong Kong, they write like this. When I write like this, it means contradiction. Or impossible. The next one, 2a1 is 2. We know z minus 1 is 2 to the a minus 1, which is 2, so z equal to 3. Now, 2 to the x equal what? Z minus 1, which is 2 times z plus 1, which is 3 plus 1, 4. 8, so 2 cubed. Now we understand x, y, z. X will be what? 3. Y is what? 0. And z is what? 3. So we found one answer. Let me draw a rectangle around this answer. So the first answer is okay. Now we've considered y equal to 0. Now we should consider x 0, 1, 2. So let's copy the main equation and we want to check x0, x1, x2. So the first case, if x is 0, then we can conclude what? 1 plus 3 to the y equals z squared. So we can say 3 to the y, subtract 1 from both sides, z squared minus 1. We factorize z minus 1. z plus 1. Because the product of them is multiple of is 3 to the power of something. So, for example, let's not use same variable. We said a1, a2. I say, for example, b1, b2. 3b1, 3b2. And by lemma 1, we can say GCD of these two numbers. By lemma 1, again, we can say GCD of z minus 1 and z plus 1 is what, 1 or 2. So now we conclude. We know this number is less than this because it is z minus 1. It is z plus 1. It is 2 more than this. So 3b1 is power of 3 and we can say, okay, because their GCD is 1, for example, if it is 3 or 9 or something else, we know it will be greater than this. It will be 3, for example, if it is 3, it is greater, it will be 9 or 27. So their GCD will be multiple of 3. For example, 3, 9 will be 3 or 9, 27. Their GCD will be 9. But their GCD can only be 1 and 2. So we conclude the smaller one should be what? Because greatest common divisor of them is 1. 2 is impossible because they are 3 to the power of something. They are odd numbers. So it can only be one number. It is what? It is 1, 3 to the 0. So we conclude what? Z minus 1 is 3 to the b1 is 1. So z is what? Z is 2. So 3 to the y is what? Z 2 minus 1. 1 times 2 plus 1, 3. So 3 to the 1. So y is what? Y is 1. Now we conclude what? 0, x 0, y 1. Z is what? Z is, we said here, 2. So we found one more answer when, let me draw it with red. We found the second answer. Now let's focus on when x equal to 1. Again, we copy this and we want to consider when x equal to 1. So here we say 2 plus 3 to the y equal to what? Z squared. Okay, now if you consider the remainder when divided by 3, okay? If I consider the remainder when divided by 3, z is, for example, 3 e or 3e plus 1 or 3e minus 1. If I calculate z squared when divided by 3, it will be 3e prime. It is multiple of 3 in this case. In this case, if you raise to the power of 2, you should use this identity, and I think most of you know that. A squared plus b squared plus 2ab. If we use that for this one, it will be 3e plus 1 squared, and you can say 3e prime, because it is 3e squared plus 2 times this, all of them plus 1. And if you consider 3e minus 1 squared, it will be 3e prime. Again, this squared and 2 times this times this, all of them are multiple of 3. 1, negative 1 squared is again 1. Because if you calculate a minus b squared, it will be a squared plus b squared minus 2a. And you will see, okay, z squared mod 3 is 0 or 1. Now, I say we considered when y is 0. So here we can, without loss of geometry, we can consider y is at least 1. So if I consider remainder when divided by 3, the first part is what? When I consider remainder when divided by 3, it is 3. It will be, for example, 3q plus 2. But this number is what? It is 3e prime or 3e prime plus 1. So the remainder of left hand side is 2. The remainder of right hand side is 0 or 1. So that's a contradiction. So for x1, we don't have any answer. If you know congruency, the students have no congruency, easily you can say, okay, z squared is 0, 1 mod 3, and the left side is 2. 2 is not equal to 0 or 1. But if you don't know why this way, you can easily understand. Now, let's consider the next part. We've considered what? We've considered x equal to 2 here, x equal to 1, x equal to 0. Now, one case is left. We want to check the case that x equal to 2. So, 2 to the 2, because x is 2, replace x with 2, plus 3 to the y equals z squared. Then we can say 2 to the power of 2 is 4 plus 3 to the y equal to z squared. And then we can say 3 to the y equal to z squared minus 4. And then we can say it is z minus 2 times z plus 2. Now here, we will see 3 to the y equals z minus 2z plus 2. So I want to find GCD of these two numbers like previous time, exactly similar to lemma 1. You say z minus 2, z plus 2. Suppose, for example, it is d1. Z minus 2 is d1, for example, times something, q1. Z plus 2 is d1 q2. So if we add up these two numbers, 4 equal to d1, q1 plus q2. We know by the definition of GCD, it is positive integer. So here d1 can only be what? D1 can only be 1 divisor of 4, positive divisor of 4, 1, 2, or 4. Now here, product of these two numbers is 3 to the power of y. So this one, for example, is 3a4. This one is 3b4. So we can say what? It is less than this because it is 4 more than this. It is z minus 2, it is z plus 2. Their GCD can be 1, 2, 4, their common divisor. So because they are odd, 2 and 4 here is impossible. So the only GCD is 1. Now, we understand it should be what? 1. Because, for example, if it is 3, then it is 9 or 27. Then their GCD will be what? Greatest common divisor will be 3. And it is impossible because their GCD can only be 1. So here we conclude 3a to the 4 is what? Is 1. Now that it is 1, we can find z. Because z minus 2 is what? 3 to the a4, it is 1. So z is what? Z is 3. Now we conclude 3 to the y is what? 3 minus 2, 1 times 3 plus 2, 5. 1 times 5 is power of 3 and its contradiction. So for x2 also, we didn't find any good answer. Now we've proved that we've considered all the cases x0, 1, 2 and y0. So we can conclude what? Let's copy the main equation, paste. X is at least 3 and y is at least 1. So here I consider what? I consider the remainder when divided by 8. Remainder or mod 8, the students know mod. Remainder when divided by 8. So the left side is what? Because x is at least 3, 2 to the x is multiple of 8. So it will be 3 to the y. And right side will be what? Z squared. I proved what? I proved, let me show you here. I proved that if z is odd, if a number is odd in lemma 2, if b is odd, b squared is 8q plus 1. So here I can say what? I can say, so let's consider 2x is, for example, 8q1 plus 3 to the y equal to z squared. Z is odd. Why? Because look, it is 3 to the y is odd. It is even. So you can say z is odd. Z squared is odd. So z is odd. So by lemma 2, we can say what? It is 8, for example, q2 plus 1. Now you say, okay, 3 to the y is 8q3 because 8q2 minus 8q1 is 8q3 plus 1. So the remainder of 3 to the y when divided by 8 is 1. Now, if you consider the remainder of 3 to the y, 3 is 3. 3 squared is 9. The next one, so you can say it is 3. 9 remainder when divided by 8 is 1. The next one, 27, is 3. The next one is 1. So 3, 1, 3, 1. So we conclude what about 1? The period is 2. 3 to the 2 is 1. 3 to the 4 is 1. So we conclude y is what? Y is even. So the first thing we conclude, y is even. So for example, we consider y is 2y prime. So the first thing we've reached. Now let's see what can we say about x. We are considering the cases analyzing the problem. So y is 2y prime, so we have 2x plus 3 2y prime equal to z squared. Now, and we know y prime is at least 1 because we've checked the case that it is 0, so we said y 2y prime, we said y is at least 1 because it is even, it is at least 2, and y prime is at least 1 here because y prime is 0, y 0, we've checked y 0 previous time. So now let's consider these two numbers when divided by 3. The remainder when divided by 3. So if you pay attention to left side, This part is multiple of 3, so the remainder is 0. Z squared is what? We've considered that. Let me show you in this part. We said Z is 3 plus 1 or 3 minus 1, so the remainder is 0 or 1 always. So the remainder of right side is 0 or 1. So now 2 to the x is what the remainder when divided by 3. Okay, remainder of 2 to the x when divided by 3, the first one 2, the next one 4, 2 to the 2. 4 is 1 remainder when divided by 3. The next one 8 will be 2. The next one 1, you can multiply. The period is 2. So it can be 2 or 1. Now we understand what? 2 plus 0 is 2. We don't have 2 here. The only possible case is 1 and 1 if I write the rest with like 1 here, 0, it will be 1. So 2 to the x, the remainder when divided by 3 should be 1. 2 to the 2 or 2 to the 4. So we conclude x should be what? X is even. So if I want to write, we can say x is 2x prime, and we said x should be at least 3 because we've considered x 0, 1, 2. So 2x prime is at least because it is even at least 4, and it's congruent equivalent that x prime is at least 2. So I say what? 2x prime, I replace x with 2x prime plus 3 2y prime equal to z squared. X prime is at least 2 and y prime is at least 1. And now we should focus on finding all the answers of this equation. Okay, now we consider what we say. Okay, suppose it is 2x prime, or we can say, let's consider this part. 3 2y prime equal to z squared minus 2 to the 2x. Both are squares, so we can say z minus 2x prime. Z minus 2 to the x prime times z plus 2 to the x prime. And now we consider these two numbers. Their product is 3 to the 2y prime. So for example, it is 3 to the a5, and this one is 3 to the b5. We know it is less than this because it is minus this, it is plus this. If we consider their GCD, the GCD of these two numbers, it is what? Suppose GCD of z minus 2x prime z plus 2x prime, for example, is d2. You know, z minus 2x prime is d2, for example, q3. Z plus 2x prime is d2 q4. And look, it's better to not use same variables in the solution if it is possible. Because now I explain for you, it is okay. But in the exam, if you write on your answer sheet, it's better to not write same variable for different things. So here, if you add up these two things, 2z equal to d2 q3, or I think it's better to subtract. If we subtract this minus this, it will be 2x prime plus 2x prime, 2x prime times 2, which is will be this, d2 q4 minus q3. So we understand d2 times something, d2 is positive. It's power of 2, so we understand d2 is 2 to the power of, for example, c. Now we know these two numbers are what? Are odd. So d2, because of this, they are odd. d2 can only be what? 2 to the 0 is 1. So this number should be what? Should be 1. Why? Because if it is 3, then it is, for example, 9 or 27 power of 3 greater than 3. And then the GCD will be 3. So if it is 3 or 9 or any other number, the GCD won't be 1. So it is similar but like previous one. So here it should be 1, and we conclude what? When it is 1, we can say something. We can say this one is 1 and this one is 3 to the b1. So z minus 2x prime plus 2x prime plus 2x prime equal to what? Z plus 2x prime. Look, this is plus 2x prime plus 2x prime. Z plus 2x prime is 3 to the power of p5. p5 z minus 2x prime is 1. So we've reached a new equation. 1 plus 2, this plus this is 2 times 2x prime is 2x prime plus 1, equal to 3b to the 5. So here, look, we know x prime is what? It is z minus 2x prime. We said, okay, x prime is at least 2. Because x prime is at least 2, so it is multiple, x prime is at least 2, it is multiple of 8, for example 8w1. So if you consider the remainder when divided by 8, it is 8w1 plus 1. The remainder of this when divided, it is 8w2 plus what or what? At first 3, then 3 squared is 9, 9 is 1. The next one 3, 1, 3, 1. So the period when divided by 8 is 3, then 1, then 3, then 1. The period is 2. So because it should be 8w1 plus 1, so it should be only these numbers. So only even numbers. So we understand B5 is even. Now that we understand B5 is even, we say, okay, 2x prime plus 1. So B5 equal to 2B prime 5. So we can say it is 3, 2B prime 5. We take 1 to right hand side, negative 1, or subtract 1 from both sides. And then I will say 3B prime 5 minus 1, 3B prime 5 plus 1. Now, because product of them is 2 to the power of something, you can say it is 2A6. It is 2b6, and then we can say what? Their difference is what? Their difference is 2. So it is like lemma 1. Their GCD is what? Like lemma 1. The GCD of these two numbers, because their difference is 2, can be only 1 or 2. It is less than this. So because this number is even and this number is even, both of them are even, so and their GCD cannot be 1 because both of them are even. So it is 2 or 4. But if it is, for example, 4, then it will be what? This one will be greater than that. The GCD will be multiple of 4, is 4. But here can only be 2 or 1, we know, because both of them are even, only 2. Because their GCD is 2, it can only be, like previous part, it can only be 2. Now we can solve the problem easily. How? We say 3b prime 5 minus 1 is 2. So 3b prime 5 is what? Take negative 1 to right side, 2 plus 1, 3. So b prime 5 is what? B prime 5 is 3 to the power of 1. 3 to the b prime 5, so it will be 1. B5 is what? B5 is 2b prime 5, which will be 2. And then we can say what? If I want to find 2x prime plus 1 is what? 3b prime 5 minus 1, which will be 3, 1 minus 1, 3 to the 1 plus 1. It will be what? It will be 2 times 4, which will be 8. And it will be 2 cubed. So x prime plus 1, 2 to the x prime plus 1 equal 2 cubed. It is 3. So x prime is what? So x prime is 2. Now, we know x was what in terms of x prime? We said x is 2x prime. So x is 2 times this. X is 4. Okay, we know x is 4. Let's write x is 4. Let's find y. Y was what here? Step by step, let's go backward. If we go here, it is 3 to the a5. It was 1, 3 to the b5 to find 3 to y prime. So b5 was what? We've calculated b5. b5 is 2. So because b5 is 2, let me write with red. b5 is 2, so it will be 9. So 9 times 1, 9. 2, 3 to the 2y prime equal 9, which is 3 to the 2. So 2y prime is 2. We said y is what? We said y is 2y prime here. So 2y prime is 2. So y is 2. And now let's find z. We can easily find z. Why? Because 2 to the 4 plus 3 squared equals z squared. It is 16. It is 9. It will be 25. There's some z squared is 25. So z will be 5. It is our last answer. Okay, if you had any question, there are around some important, for example, ideas in algebra, number theory that are useful in, also around 50 important formulas in geometry, combinatorics. We have around 40 important ideas. If you want to learn them, feel free to send message to my WhatsApp number in the description. So here are all the answers. We have 3 answers. The first answer was what? 303. The next one 303012, and the last one is 425. If you had any question about the solution of this problem or other problems, or want to learn the ideas that you'd be able to solve hard problems and can pass round 1, round 2 of any Olympiad and reach to IMO, feel free to send message to my WhatsApp number. Thanks for subscribing and like the video. And also, if you click on my other videos and use my playlist, you can improve your problem solving. Harvard, MIT, Stanford math tournament, any of those playlists and videos, step by step you can improve your problem solving. Thanks for watching the video.